there. Now we're ready to look at the second part of our lesson 11 video dealing with the concepts of particle motion, position, velocity, acceleration as it relates to particle motion on a horizontal or vertical line. Get my, oops, nope. Okay. So we have information given about a particle moving along a path such that its position on the path is given by that function for t is greater than 0. So the velocity of the particle, well, the derivative of position is the velocity. And so that's going to be 6t squared minus 24. Okay. So at time 1, that's going to be 6 minus 24, or negative, make sure I don't make a dumb mistake here, negative 18, and that's centimeters per second. And then the velocity at time 6 is 6 times 6 squared minus 24, which is a big number, 6 cubed minus 24, 192 centimeters per second. If they don't give you any information about units, then we just don't include units. If they do give you information about units, you should include them, and it usually prompts you to make sure you include units. Okay, so velocity in this case, since the position is measured in centimeters, time is measured in seconds, my velocity is going to be in centimeters per second. When is the velocity 0? So velocity equal to 0 is what we're looking at here. So 6t squared minus 24 equal to 0. A couple different options for solving this. If you want to factor, just get a little algebra 1 going. So factor out of 6. So then 6t minus 2, t plus 2 equals 0. So algebraically, my solutions are 2 and negative 2. But in the context of the problem, oops, I'm gonna sneeze too. At t equals 2 seconds. T has to be greater than 0. So, this is a scenario where the algebra gives us one set of solutions. The solutions that are correct algebraically may not be correct contextually in the context of the problem. Just like when we do, we've talked about extraneous solutions before, you may or may not remember that from pre-calc and logs. But some solutions just don't make sense based on the original problem. Based on the context of this problem, negative 2 seconds doesn't make sense. So the correct answer for part B would only be 2 seconds. And in a multiple choice scenario, you may have the choice that says 2 and negative 2, and that choice would be incorrect. Determine the acceleration at 1 second. Well, my acceleration function is the derivative of my velocity function. So that would be 12t. So at 1 second, that is 12 times 1, or 12 centimeters per second, because it's the velocity unit compared to time, or 12 centimeters per second squared. And now here comes our favorite answer, our favorite question. Are we speeding up or slowing down? Okay. The justification for a speeding up and slowing down concept has to be a discussion of both velocity and acceleration. So my velocity at time 1 and my acceleration at time 1 both need to be a piece of this discussion. Right, so my velocity at time 1 was negative 18 centimeters per second. And my acceleration at time 1 was 12 centimeters per second per second. This then means that my object, my particle, is slowing down. And the best way to describe this, the easiest, smoothest justification, is to say, I know that's happening because the velocity at 1 and the acceleration at 1 have opposite signs. We can go into a lot of other explanations about this, and we can get deeper into the physics of it. The problem is we often do that incorrectly, number one, and number two, that's not required. The calculus of this is the relationship between the signs of these two measurements. If the velocity is negative and the acceleration is positive, the particle is slowing down. I know that's hard sometimes to understand, because if you're like acceleration is positive, means going faster, accelerating, because you're only thinking about that in the context of driving a car. Okay. But let's look at what this says. If my velocity is negative 18, and it's changing at a rate of 12 centimeters per second, just think about that in a one step. A negative 18 accelerating at 12 is to a negative 6. Speed-wise, that's an 18, because speed is the absolute value of velocity, to a 6. That's slowing down. We tend to think speed. And when we reconcile it in our mind, we think our everyday experiences with driving a car, which have nothing to do with a negative velocity. Okay. Don't try to give me fancier physics descriptions. The problem oftentimes with doing that, like I said, is you often do that incorrectly. Okay. And it takes time to write a longer description. This is all you have to say. We know they're slowing down. How I know? Because the velocity at 1 and the acceleration at 1 have opposite signs, and there's the evidence of that because I have their values. Okay, let's make it as simple as possible. Okay, next we have the moon problem, and which is it's a gravity problem based on the force of gravity on the moon being a little different than Earth. So velocity function in this case and acceleration function, you're just writing the derivatives. You can pause at this point and check those before I write them. Okay, so negative 5.4 t plus 27 would be my velocity, and acceleration would be negative 5.4. The time when the object is at its highest point. Right? Well, when you throw something, it's going up, 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 and then it stops instantaneously, and then it starts to fall down. So when we're stopping, that's our velocity equal to 0. So that is how we're going to figure that out we're going to set my velocity function equal to 0. And I'm going to solve that. So -27 divided by -5.4. And t is 5 seconds. What is the height at this time? That's a position question. So that's -2.7 times 5 squared plus 27 times 5 plus 6. There's a good chance you would have a calculator for a question like this when you have to do this amount of calculation. Another option on this, as weird as it's going to sound, is, as far as the AP exam goes, if this is a free response question, that's actually considered an okay answer, just like that. Completely unsimplified. I know that seems completely crazy, but that is considered an okay answer, and that would be in feet. However, if you do calculate that out, that's 73.5 feet. Okay. All right. In part 3, we're going to go on and talk about some of the multiple choice questions, which are going to focus on looking at a graph. Namely, a graph of, I believe, in most cases, a graph of velocity. Yes, so graphs of velocity and some questions relating to those coming up next.